To explain the effect of the spin, we analyze two different liquids under ultraviolet rays. The electrons get activated by the ultraviolet rays, so they can change from HOMO, highest occupied molecular orbital, to LUMO, the lowest unoccupied molecular orbital. The electrons stay in the upper orbital just 10 to the power of -8 seconds, and while the electrons are still under the influence of UV radiation, they fall back to the orbital where they originally came from. Because of the energy loss of electrons while they fall back, this energy is transformed into visible light. In the way as with the fluorescence, the electrons switch from HOMO to LUMO by getting activated by the UV radiation. The difference in this case is that one of the electrons in the upper orbital makes a spin flip. But what's a spin flip? In every orbital are two electrons which both have a negative charge. Normally they would push themselves off, but after the principle of Pauli, the electrons have rotation in and against clockwise direction, which is called spin. This rotation produces a magnetic field. If they have a different spin, they pull themselves in, and if they have the same one, they push each other off. The spin flip causes the two electrons in the orbital having the same spin push each other off. Because of the repulsion, they can't fall back to the orbital below. This process ends as soon as a particle hits the electron and causes change of the spin, so that the electrons pull each other in and can fall down. The same way as in the fluorescence, this produces visible light. If you turn the UV light off, it luminescences a few seconds or longer, till the electrons are hit by a particle.